This is section 4.8, part 1, where we are going to learn about the quadratic formula and then learn how to use it to solve quadratic equations. So in order to use the quadratic formula, you want to make sure you have a quadratic equation that's in standard form. So that's ax squared plus bx plus c, where a, b, and c are going to be helpful to us, because we're going to take those numbers and plug them into this formula right here, which is the quadratic formula. So you can see it's x equals the opposite of b plus or minus the square root of b squared minus 4ac, and that's all over the product of 2a. And so we're going to use that multiple times. So first thing which we're going to do is we're going to come down and we are going to use the quadratic formula to solve equations, and we're going to find two real solutions. Alright, and so what that means is the parabola is going to cross the x-axis in two spots. So we've got a little note written down here in red which says we want to make sure we set our equation equal to 0. So in order to get in standard form, we've got to have all the terms from one side of the equation moved over to the other, so there's just a 0 on this side. So I'm going to do that by subtracting 4. And we've got x squared minus 5x minus 4. 4 minus 4 cancels, so we're left with 0. Now we have a nice quadratic equation in standard form. Ax squared minus bx, and then we've got a minus c, where my a value here is the number in front of the x squared, which is 1. The b value is the number in front of the x, which is negative 5. And my c value is my constant, the number over here that's not attached to a variable. That's negative 4. So we're going to use those to solve using the quadratic formula. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in the correct values. So the opposite of b, or the opposite of negative 5, plus or minus the square root of negative 5 squared minus 4 times a, which is 1, times c, which is negative 4. And that's all over 2 times my a, which is 1. So we've got x equals the opposite of negative 5, which is positive 5, plus or minus the square root. Negative 5 squared is positive 25. Negative 4 times 1 is negative 4. Negative 4 times negative 4 is positive 16, so I have a plus 16. 2 times 1 is 2, so it's all over 2. Then we have x equals 5 plus or minus 25 plus 16 is the square root of 41 all over 2. And you want to simplify this as far as you can. What you don't want to do is to convert this to a decimal. Right, so if I were going to come into my calculator here, let's quit out of this. If I were to try and see if square root of 41 was perfect, which we know it's not, alright, you're going to get a decimal. You don't want to convert it to a decimal, and you don't want to round, because it won't be an exact answer. You want to keep it in square root form if it's not a perfect square. But what you do want to see is you want to see if you can simplify the square root of 41, or any square root that you get here, because you want to have it in most simplified forms. You want to make sure that that square root is simplified. Lucky for us, our square root is simplified, so the square root of 41 can't be broken down. So we're going to leave our answer just as this. Alright, where x equals 5 plus or minus the square root of 41 over 2. And that actually gives us two different roots, because 5 plus the square root of 41 divided by 2 is going to give us a different answer from 5 minus the square root of 41 divided by 2. And so just to confirm that we are in fact getting two roots, I've gone ahead and plugged in our problem into our calculator. Sorry, my calculator's not sliding over at all. Alright, so we've set the problem equal to 0, so it's x squared minus 5x minus 4. That's what I've put in here, and I want to graph it. So I'm going to go to zoom 6, and we're going to get a nice visual representation of what this graph looks like. And we do in fact have two zeros right here. This is 5 minus the square root of 41 divided by 2. And this root here would be 5 plus the square root of 41 divided by 2. And that's part 1.